Hello, dear students. Today we're going to do Proposition 26 from Book 1. Proposition 26. If there be two triangles such that two angles are equal to two angles and one side equal to the other side, then those two triangles will be equal. The angles will be equal and the rest of the lines will be equal, of course. Okay? So we have two possibilities. It's either going to be angle, side, angle, or angle, angle, side. Once we do this proposition, we're going to have, in any case, we've done in Proposition 4, side, angle, side. We've done side, side, side. If the three sides are equal, the triangles are equal. Now, the only other possibility, we're going to prove it today, when two angles are equal and one side is equal, those triangles are equal. The only thing is, we've got two possibilities. Where is that side located? Is it located between the equal angles or not between the equal angles? We're going to prove this proposition for both cases, just to be sure, okay, just so that we really know. So in this case, what's given? That this angle and this angle are equal to this angle and this angle respectively, and this side is equal to this side. We need to prove then that the other sides are equal and the triangles are equal, okay? So we're going to start by picking on this side, and we're going to say that these are equal. For if not, we're just going to do a little reductio ad absurdum. If not, they're unequal, and one of the sides is greater. Let this one be greater. It can be shown for either case, but let this one be greater, okay? Now let's cut from the greater a line equal to the lesser, okay? Cut it, and then cut it here such that this now is equal to this. I'm going to do it with black, I think, just to not confuse. Connect these two lines, and we have this little angle here, okay? Now, we can use side, angle, side. In this proposition, we're going to use side, angle, side, and the proposition about the exterior angle being greater than the interior one, okay? But right now, what we have is side, angle, side, side, angle, side. So we know that this triangle, with this one right here with the black base, is equal to this one, according to our supposition. Okay? So that means that the rest of the angles are equal. So this red angle is equal to this red angle. But this red angle was given that it was equal to this whole angle that's now made up of red and black. Okay? So that means that this red and black angle, this whole angle, is equal to the part, the red part. Okay? So the whole being equal to the part. That doesn't make any sense because we know the whole is greater than the part. So this thing cannot both be equal to the whole and greater than the whole at the same time in the same respect. Again, let's review why they're equal. Because we use side, angle, side, side, angle, side, the angles are equal. This little angle is therefore equal to this little angle according to side, angle, side. But this black angle, this red angle was given to be equal to this big whole angle. Therefore, this big whole angle is equal to its part, and that's absurd. So it can't be that this is greater than this. Likewise, it can't be that it's less than this because then this would be greater than this, and you just do the same proposition on this side, and you get the same result. So if it can't be greater than it, and it can't be lesser than it, it must be equal to it, okay? So there we have angle, side, angle. Now let's go over here and show angle, angle, side, okay? Angle, angle, side. We have two triangles such that two angles are equal to two angles, respectively, and one side is equal to the other side. But that, in this case, the side that's equal, that's given to be equal, is not in between those two equal angles, okay? It's not given. What's given is the equal one is outside of those equal angles. Great. Let's prove it now. Let's prove that this side is equal to this side, okay? If they're not equal, then they're unequal. One of them is greater. Let this side be greater than this side. A little reductio ad absurdum. Cut it, say here, such that now this is equal to this, okay? Let's connect these points. Okay? Now we're going to have side, angle, side. Let's invoke side, angle, side. Two triangles with this black base now. Side, angle, side. Side, angle, side, up to here. Therefore, the triangle, the base is equal to the base, the triangle is equal to the triangle, and the remaining angles are equal to the remaining angles. Therefore, this angle is equal to this angle. But it was given that this angle is equal to this angle. Okay, so if this is equal to this, and this is equal to this is equal to this, because two things equal to the same thing are equal to each other. We've got a problem here, because here we have a triangle with the exterior angle equal to the interior and opposite angle. But we know from proposition, I don't remember, 16 maybe, that in any triangle, the exterior angle is always greater than the interior and opposite angle. So it cannot be the case then, once we granted that this was greater than this, we came to an absurdity, that this is both equal and unequal to this. This angle is both equal and unequal. Likewise, if you said, okay, we'll let this one be bigger. Same problem, okay? So we know that this can't be greater than this, it can't be less than this, therefore it must be equal to this. Therefore, we have shown that in any two triangles, if two angles are equal to two angles, and one of the sides of those triangles are also equal, the triangle is equal to this triangle, and the remaining angles are equal to the remaining angles, and the remaining sides are equal. Thank you so much. Bye-bye.